Good afternoon. This is Mr. Park, and today in economics, we're going to learn about game theory and oligopoly. I'll go over briefly how to um, look at a game theory matrix. This is a homework that was provided, so we'll review it really quickly, and then I'll go over an example from the 2019 AP Macro FR2 as an example. So let's go ahead and get started here. So I'm going to share my screen right here and take a look at this game theory. Again, this was assigned as homework, so hopefully you're a little bit familiar with the content, but I'll go ahead and take any questions if there's anything that you don't understand here. But let's go straight into this matrix here. So player A either has strategy 1 or strategy 2. I kept it really generic just so that you just get an idea or a feel of how this actually works here. So player A can either choose strategy A or strategy 2, and player B can choose strategy 1 or strategy 2 as well. And if you look at box A, B, C, and D, those are the outcome boxes that can result when either player A or B, when they combine to make decisions. But again, keep in mind that player A or B are not choosing box A, B, C, or D. They're choosing either strategy 1 or strategy 2 here. So I broke it down this way here. So if you could take a look here. For player A, again, player A is the X player. Player B can choose strategy 1 or strategy 2. And when they choose strategy 1 or strategy 2, then player A can either choose either strategy 1 or strategy 2 as well here. So again, let's say that player B chooses strategy 1, then player A can either choose strategy 1 and get $100 right here. So that would be the X value right here. Or player A can choose strategy 2 and get a $200 amount right here. Now, clearly the $200 is better than $100, so that's why I have a check mark next to the $200 mark, right? Now, let's say that player B chooses strategy 2, right? Then again, we're going to cross this out here. This is no longer relevant. And player A chooses strategy 1, then the amount would be $0. Now, player A chooses strategy 2 as a result, then he's going to get $50, right? So again, player A choosing strategy 2 is the better of the two options. This is referred to as dominant strategy, right? Now, if you take a look at player B, it's going to be the exact same situation because the numbers are exactly the same. So we're going to move straight on to another example using a different scenario here. Okay, so I'm going to clear this screen right here and then scroll down to Cassie and Miley, right? So in this case, Miley is the X player and Cassie is Y player. And again, you have A, B, C, and D here. And let's take a look at Miley's perspective, right? So again, same scenario here. If Cassie chooses high, so again, they're selling, I think the situation I use here, they're selling boba, and they can either choose to sell the boba at the high price or the low price, right? Now, the collusive outcome would be for them to choose box A. But again, keep in mind, they're not individually choosing box A, B, C, or D. They're only choosing to either sell at a high price or a low price, right? So if Miley, if Cassie chooses the high price right here, again, Cassie chooses the high price right here, then Miley can either choose between the high price and get 400 or the low price and get 200, right? So clearly the high price is better for Miley, and that's why I have a check mark right here. Now, if Cassie happens to choose the low price, then Miley can either choose the high price and get $300 or the low price and get $500, okay? Now, again, I put a check mark next to the low. Now, notice how this situation is a little bit different than the previous situation because if Cassie goes high, Miley goes high. If Cassie goes low, Miley goes low as well. So there's no dominant strategy in this case for Miley because Miley's decision is dependent on what Cassie has done. Now, again, these numbers are not nice and the same as the previous example. So let's go ahead and take a look at Cassie's situation right here. So again, I broke this down here. If Miley chooses high, then Cassie can choose high and get 500, or she can choose low and get 600. As you can see from this chart here, Cassie's better option is to go low. Now, if Miley chooses to go low, Cassie can choose high and get 400, or she can choose low and get 800, right? So in this case, Cassie has a dominant strategy, whereas Miley does not, right? Because no matter what Miley chooses to do, Cassie is better off going low. So you have a situation here where Miley has a dominant strategy, or Cassie has a dominant strategy, but Miley doesn't, right? So let's go ahead and take a look at this this scenario here and see how that plays out here. Okay. So again, we know that Miley or Cassie does have a dominant strategy of choosing low. So no matter what, she's going to choose low right here, right? And so this high is out of the equation here. Now, if Cassie goes low, Miley's better off going low as well, right? So Cassie has the competitive advantage because her decision is not dependent on what Miley does, but Miley's decision is dependent on what Cassie does. And so they're going to end up in box D right here. And this is what's known as the Nash Equilibrium, because that's where they're going to end up. Now, in the previous example where both of them had a dominant strategy, where they play their dominant strategy would also be called the Nash Equilibrium. In this case, even though Miley does not have a dominant strategy, because Cassie does have a dominant strategy, the Nash Equilibrium will be where they both end up being at the low price here. So again, that's one example. Another example here is what happens if there's a situation where neither of the players has a dominant strategy, right? So let's assume that Sony and Microsoft are the players here. So let's use some companies. As you know, Sony has a PlayStation console that they come out with, and Microsoft they come out with their Xbox console, right? And so they operate in an oligopoly type market where there are a few players that dominate the video game console industry. Well, let's assume that they have a choice between coming out with a new product either early or late, right? So the boxes are, as shown, A, B, C, or D. But keep in mind, Microsoft and Sony cannot control what the other person does unless they collude together, and they can either choose either early or late, right? And so I break it down right here. For Microsoft, who is the Y player, if Sony chooses early, then Microsoft can either go late or early. And again, choosing late will yield the higher amount. But if Sony chooses late, Microsoft is better off going early. So again, Microsoft does not have a dominant strategy, right? So Microsoft, their choice is dependent on what Sony decides to do. And again, the same situation applies to Sony. If Microsoft chooses early, Sony should choose late. And if Microsoft chooses late, then Sony should choose early. So in this situation, neither has a dominant strategy. But let's take a look here how the Nash equilibrium would look a little bit different right here, right? So, so again, if Microsoft chooses early, then Sony can either choose the 4 million or the 10 million. So they're going to go with the 10 million, obviously, right? Because 10 million is better. So they're going to choose late here. Now, if Microsoft chooses late, Sony's going to go early because 7 million is greater than 3 million, right? Now, if Sony chooses early, Microsoft can either choose between 4 million or 8 million. 8 million is better, right? Now, if Sony chooses late, Microsoft is going to choose early because 10 million is better here. So the Nash equilibria in this case would be Microsoft going early and Sony going late, or Microsoft going late and Sony going early, right? So this is what's known as the Nash equilibria because there are 2 points. And then let me show you why this is the case, right? In a dominant strategy equilibrium, there's no incentive to change regardless of what your opponent does, right? So if you choose to go low and your opponent has gone low, if your opponent chooses high, you have no incentive to switch your choice. In this case here, let's say you're Microsoft and Sony has chosen to go early, then your best choice is to go late. Well, if Sony chooses to go late, now you have an incentive to switch your play to early. And so you're going to switch from the late column to the early column. And that's why there's two Nash equilibria. It's B and C, because your play is going to switch depending on what your opponent is going to do. Okay, so that's basically what you're dealing with in terms of finding Nash equilibria. Now, there's a variety of different scenarios that you can have where there's two dominant strategies, one dominant strategy, one having no dominant strategy. You can have no dominant strategy, and there's something called a prisoner's dilemma where there is a dominant strategy for both, and there is a collusive outcome. And so there's a variety of different scenarios. One of the things that to remember is that the 2020 version of the AP FRQ exam, there's a little bit more of a prominent place for game theory. And so let's take a look at the 2019 FRQ that they did with game theory, and let's go ahead and work that one out here. So we're going to use that. It's going to look very similar to it, and so I just want to show you that the example I gave hopefully will give you a foundation to be able to succeed on this particular exam here. All right, so let's take a look at this here and see how we can attack this problem here. So this was a question number 3. So game theory tends to be either, rarely will you see question number 1 as the game theory question. Usually it'll be the question number 3 here. So you have Jackpot, Florist, and Boulevard Gardens. They share the market for floral bouquets in Tulip Town. Jackpot is, hold on a second here. Okay, so Jackpot, Florist, and Boulevard Gardens share the market for floral bouquets in Tulip Town. Jackpot is deciding whether to close at 6 p.m. or close at 9 p.m. And Boulevard is deciding whether to offer delivery or no delivery. The payoff matrix above shows the annual profits for each combination of actions that the firms can choose. The first entry shows Jackpot's profits, and the second entry shows Boulevard's profit here. So I'm going to go ahead and annotate here so you can see here. So what I underline in blue, that's going to be the profit entries for Jackpot, because Jackpot is the X player here. Now, what I underline in red, that's going to be the payoff for Boulevard, because they're the Y player. Okay. So let's take a look here. Assume that both firms know all the information in the matrix and act simultaneously and independently, meaning that there is no collusion. Is Jackpot's dominant strategy to close at 6 p.m., close at 9 p.m., or does it not have a dominant strategy, right? Notice here, there's no explanation here. So you have a 1 in 3 chance of getting this right. So for this particular question, if you have no idea, then it would behoove you to actually make a guess, because there's no explanation point here. So that's a test-taking strategy right there, right? So, so if Boulevard chooses deliver, then Jackpot can either choose 35 or 25, and clearly the 35 is better, so 6 o'clock is better. If Boulevard chooses no delivery, then it's either 45 or 55, and 55 is better. So lo and behold, is there a dominant strategy? Yes, there is, and it's to close at 6 o'clock. So 6 p.m. is the correct answer for that. Okay. Now, suppose that so for part B, suppose that Jackpot chooses 6 o'clock and Boulevard chooses no delivery. Well, this one's even easier, I think, here, because then Jackpot chooses 6 o'clock and Boulevard chooses no delivery. Is this the profit maximizing output? So you take a look at this here, 20 is the profit with no delivery, but 30 is the profit maximizing with delivery, right? So is this a profit maximizing amount? No. Why? Because $30 is greater than the $20 that's going to get here. Now, let's take a look at the Nash equilibrium. So how much profit will Boulevard earn in a Nash equilibrium? Now let's take a look here. So we know that Jackpot does have a dominant strategy, right? And we determined that 6 o'clock is the choice, right? So if Boulevard chooses delivery, Jackpot will choose 6 p.m. If Boulevard chooses no delivery, the Jackpot will also choose 6 p.m. here. So what we can do here, just to simplify things, we can eliminate this here, because in no world will Jackpot choose 9 o'clock, right? So given this here, we don't even have to know if Boulevard has a dominant strategy or not, right? And we do know that they actually do have a dominant strategy because 40 is greater than 20 and 50 is greater than 30. But because we know Jackpot is going to choose 6 p.m. no matter what, then we can operate under that assumption, right? So if Jackpot chooses at 6 p.m., then delivery would be 30 and no delivery would be 20. And therefore, this option is going to be a Nash equilibrium. I mean, you can label this as box A here, but the Nash equilibrium basically is such that Jackpot is going to choose 6 p.m. And Boulevard is going to choose delivery. So again, the question is, suppose these two firms merge to form one company and still face the same actions and payoffs. Which strategies would the new company choose to maximize its combined profit, right? So even though, okay, so again, C, the profit at the Nash equilibrium would be $30, right, for Boulevard, right? But in terms of D, what happens if it's the case where they do collude and they want to maximize profit, right? So basically, D is reversing the situation and saying, what would they do here? So I'm gonna go ahead and erase some of the stuff given here. Okay, so in this case here, all you would have to do is you would add up the different categories here and say if they do merge together as one company, then the combined profit of delivery and 6 p.m. would be 35 plus 30, which would be 65. No delivery right here, and no delivery and 6 p.m. here would be 75. Delivery at 9 p.m. would also be 75, and lo and behold, no delivery at 9 p.m. would be 85 here. So this one here is a simple matter of combining using, your math skills to determine, okay, 65 total right here, 75 total right here, 75 total right here, and 85 total right here. So assuming that they're able to combine the company, they don't have to worry about the strategic interaction of what they choose. Now they can actually choose box A, B, C, or D. And clearly, the fourth box, which is the 85 box. So what strategies would the new company choose to maximize combined profit? Then Jackpot would choose 9 p.m. and Boulevard would choose no delivery. So thank you for tuning in for the lecture on game theory, and I hope to see you next week. Have a good day.